So hello everyone, this is Pratyush. I'm from the team Data Innovators, and today we are going to do the data analysis of Munnar dataset. So starting from what is Munnar, we will know what is Munnar. Munnar is actually a town in Kerala, and it is obviously a hill station. So it has various tourist places, and various tourist places attracts a lot of hotels, and it does. We are going to do the analysis of the same today. So the IDE that I have chosen for this data analysis is Google Colab. So Google Colab is one of the best IDE I have used for Python and data science. So starting with this working on this data set today, we are going to do two tasks. That is, one is the data cleaning, and another one will be data visualization. So starting with the data cleaning, I've imported the pandas library, and yeah, in case of data visualization, there are few questions like what is the distribution of hotel ratings, how do hotel prices vary with their star ratings, what is the distribution of reviews for hotels in different location, as well as how does the distance to the nearest landmark affect the hotel price, which hotel have the highest and lowest taxes, and how do they compare in terms of rating and price. We are going to do visualization and going to find out the answers to these questions. So while using the using this IDE, like using this Google Colab, we need to have this Munnar dataset, the CSV file in our Google Drive itself. Like I have this Munnar.csv file in my Google Colab, and in my Google Drive, and in that datasets folder, I have this Munnar dataset, and I can copy the path from here and paste it here. Like usually most of us use Jupyter, which is also a good IDE, but this is much faster. I find it this is much faster than Jupyter, so I am using Google Colab. So I have imported the data, and we can see like this is our data frame. So as soon as I have imported the data, I have checked the shape and size of check the shape and size of our data, and we can see that we have 74 rows and 10 columns, which constitutes together to have 740 entries in our data set. So by checking the DF info, I can figure out that what tasks I can go on for, like to objectify for our data cleaning task. So we can see here that the tax, price, and distance to landmark, these are all numeric. These all should have numerical data types, but these have object data types, and we will we will first convert these object data type to float data type. After that, we can see the star rating has the non we can see some null values in the star rating as well as in tax column. So we will deal with these values as well. Apart from that, I have checked the columns, and we can observe that there is some unnecessary suffix in the hotel name. So by observing these things, we can conclude that there are three objectives of our data cleaning. One is change the name of the hotel name. Second, change the data type of distance to landmark, price, and task into float 64. And in the end, we will deal with the null values of star rating and tax. So starting with the renaming of this column name, the hotel name, we have used df.rename to change the hotel name, and we can see that the name of the hotel has already changed. We can see here the hotel name. It used to first look like this, but now after proper indexing and renaming, we can see that it is in the proper form now. So next, checking out the DF info, the next task is to change the data type of data to distance to landmark. So first, let's check that why distance to landmark is considered as object and not as any float or data type. So first, we will check the column by using LOC, df.loc. So we can see here that lots of entries here are in kilometers and some are in meters. So uh, first what we will do, we will convert this the values in meters into kilometers. So while by using this function to go, which converts the values from meter to meter, is a user defined function in which I've split the values uh, in this split the values of this, and like kilometers, like the values which are in numerical values, so of which shows the distance or distance of the landmark, distance to the landmark. So we can split the values, and the values which are in meter we can divide it by 1000 and then convert it into, which apparently converts them into kilometers, and the values which are already in kilometers we can return the same, and then we can place the we can apply this values to the distance to landmark column. And as we can observe that here it was 950 meter, and after getting converted it has been converted to 0.95 kilometers. So now it is ready to get converted to float data type. So using as type, we can we have successfully converted it into float 64, and to check that we can use df.info, and here we can see first it was object, the data type was object, but now it's float 64. Then next we have to deal with price. So in while by checking the price column, I can see there are commas in our in the values of the of our price values. So what we will do, we'll remove the commas, and as we have removed the commas, we can see here that now we can, like, it is ready to get converted into float 64, into float data type. So using similarly using the as type, we have converted into float, and now we can see the price has also float 64 data type. Next, we similarly I can see even the tax, the values of tax, the data in the tax column has the same issue, and we have removed the commas and then make it eligible to get converted into float 64, and that's what we have done. We can see here that tax is also converted into float 64. Next, now we have to deal with the deal with the null values of star rating. So first we will check the value counts of star rating, and we can observe that for the rating star rating 4.0 has uh, highest maximum number of records. So we can use it to fill the null values. So by using fill any, we the maximum values of the maximum values, which is 23, we have added into the null values, and then now we can see that there are no null values in our star rating. Another thing, it was in a flow it had a float data type. If we can see previously it had a float data type, but this, I think this should have the int data type, as it is a rating column and it has limited number of entries. So we have converted into int data type. And the last thing that we are left for data cleaning task is to convert the tax, not convert, fill the null values of tax. So here we have used up from mean median mode, we have used the median to fill the median values of the task data, which will fill the null values of a task column. And then we can see now our data is very crisp and clear. It has proper data types, as well as uh, literally no null value. So our data cleaning ends here. Now we can see the new data frame that which is eligible, and it's very good to go for data visualization. So let's start with data visualization. Firstly, for data visualization, we will see some basic data visualizations that we are going to perform, on the data set itself. After that, after performing on data set, we will see some basic visualization on using plots, and after that we will move towards uh, our questions that we have formed ourselves, and we are going to answer to return the value of this Munnar dataset. So firstly, we have used df.style, which like adds the additional functionalities to the data frame, which allows us to do various types of visualization in datasets itself. So firstly, what we will do, we'll highlight the values which are less than the average of the price value, and then give the yellow color to and give them the yellow color, and if the values are higher than the price value, then it will give the green color. So we can see here the data in this data, the column data, we can see here the all those values which are greater than, which are greater than, which are less than the average value, it has yellow color, and which are more than the average value of the price, it has uh, green color. Similarly, moving forward, we can highlight the minimum and maximum values of the data sets, and we can see here the minimum and maximum values highlighted with different colors. So another thing that we have used here is background gradient for visualizing data and identifying patterns. So lighter the shade here, low like lower is the value, and darker the shade, higher is the value, and that is how we can observe here, the lighter shade here, the value is 2.20, and the darker shade has the higher value, that is 21.60. After this, we have used the bar charts on the columns itself. So we can see your price, tax, and rating has its uh, it helps us to identify the values of these columns using bar charts, that which value is greater and which value is lower. And as we have used only single color here, we can use different colors as well. So like in price data set, I have used blue color, in tags green, reviews red, and rating cyan color. So we can use different colors to get or to identify the values of our data set. So here we will use dist plot, like starting with the plotting. So here we have imported the matplotlib library and seaborn library for plotting our data. So this plot here, this represents the distribution of continuous variable. So, and the KDE here is the kernel density estimation, in which is a way to estimate probability density function of a continuous random variable. So what is continuous random variable? So these are the variables that can take infinite number of real values within a given interval or a range. So example, height, body weight, age can be called continuous data variable. And another type of data variable is discrete data variable, which takes certain number of limited values. For example, uh, number of planets in in our solar system. So here we do not have the discrete variable, we have continuous data variable, and it has given the dist plot of rating, or distance to landmark, price, and tax. Now you may ask that why it has chosen only these columns. There were other columns as well. So just just as I said, it takes the continuous random variable of numeric variables. So it has to be numeric. So these all had numeric values, and it went with the just like that we went with the numeric values. But here we cannot identify the average or median or outliers. So for that we used box plot. So box plot help us to show us this show us to identify median using this line, and using this represents the interquartile range, and these dots represents the outliers. And same with the bar plot. Bar plot shows we some kind of correlation or uh, relation between different values or within the same values. Like we have used rating, and here we can see that what is the frequency of these like 2.8 has this number of frequency, three the hotels having 3.1 has two, like there are hotels with 3.1 star ratings. There are more than 8 hotels with 3.9 star ratings. There are more than 10 hotels with 4.2 star ratings. So this is how we can use bar plot for by using rating, which can help us to analyze that what is the maximum number of rating and what is the maximum number of hotels with that rating. After that, similarly we have like checked the bar plot, like using rating description. So using the rating description as well, we can identify which hotel has which how the description of rating and how much is their frequency. So now starting with the questions that were related to dataset, we will start with the first question. So what is the distribution of hotel ratings? So for this question, I have used histogram, and this is the plot. This is the histogram that we have made. We're using this code. So we used histogram because a histogram is a graph that is used to represent the frequency distribution of a few data points of one variable, and our one variable here is rating. So the distribution of hotel rating is skewed towards higher ratings, and indicating that a majority of hotels have a good excellent rating, and most hotels are rated between 4.0 and 4.5 50, and there is a moderate spread of ratings from here to like from 3.75 or 3.75 to 4.50, and we can see the variation in hotel quality but with the general trend and towards positive ratings, and there are no significant outliers, meaning most ratings are within the expected range without extreme low or high values. So moving toward next question, there is how do hotel prices vary with their star ratings? So for this, I have used box plot. So why I have used box plot, I'll show you after showing you this box plot. So we can see here how this box plot is displaying our interquartile range as well as outliers and the median value. So we used box plot here because box plot shows how the data is distributed, and it also shows if we have any outliers. It is useful way to compare different sets of data, as you can draw more than one box plot per graph. So hotel prices increases with star ratings, and there is a clear positive correlation between star ratings of a hotel and its price. Higher star ratings generally indicate higher prices, and there is a greater variability in higher star ratings. So we can see that 4 and 5 star hotels exhibit more price variation, indicating a wide range of amenities and luxury levels within these categories. And we can see that there in the luxury segment distinction, 5 star hotels have the highest prices and the greatest spread, highlighting the diversity in luxury offerings and catering to premium segments. Continue with the next question. So here we have the next question, that is what is the distribution of reviews for hotel in different location? So to answer this question, we have used the violin plot. So this is a violin plot. It's actually quite big, so it's not getting fit in the screen, but I'll try to show you. So we have used violin plot because violin plot depicts distribution of numeric data for one or more groups using density curves. So these are called your density, these are your density curves, and like they are used to show the distribution of numeric data for one or more groups. So there are certain locations such as central Munnars have hotels with fewer reviews overall, indicating possibly newer hotels or less popular. So and there are high variability locations like Lakshmi Estate and uh, Pallivasal. So here we can see these are very high variability locations, and which has like in high variability in the number of reviews, indicating a mix of both popular and less popular hotels and popular locations. And others have a significant number of reviews on average, with some outliers suggesting very popular hotels. Next, uh, here with the next question, how does the distance to the nearest landmark affect the hotel price? So the distance to the near to get answer to this question, I have used heat map. So heat map will show the correlation values in a color coded matrix, which can help in understanding the strength of relationship between multiple variables and calculate the so while calculating the correlation matrix, we are using distance to landmark and price for this heat map. And like why we have used heat map, I've already told. So this heat map indicates that the distance to the nearest landmark does not have a significant direct impact on hotel prices. Instead, the hotel prices are more influenced by their star ratings, and high star rated hotels maintain high prices irrespective of their distance to landmarks, suggesting that other factors such as amenities and services play a more crucial role in determining the price. Lower star rated hotels show more variation in prices based on distance, but the overall trend is less clear. And moving towards our last question, which hotel has the highest and lowest taxes, and how do they compare in terms of rating and price? So first we will check the highest hotel with highest tax and lowest tax, and we here I have used bar plot. So we can see here the using the price lines, and in here in the bar plot we can see the difference between the highest and the lowest tax price hotel. So the highest tax price hotel was Panoramic Gateway, and uh, the lowest tax price was of Queens of Munnar. So we have used bar plot here because it shows the relationship between numeric and categoric variable, and this bar plot is combined with a line plot. It effectively shows us the hotel and the highest and the lowest taxes and compares their ratings and prices. This visualization helps identify how the tax levels with each other factors like rating and price. Thank you so much. This is where our data visualization ends, and here we complete with the analysis part of Munnar dataset.